Alrighty, so this is problem 2 from test 2, and here we have a circuit. We're supposed to use source superposition to find V1, the component of V0 due to the 9-volt voltage source alone, V2 due to the 6-volt voltage source alone, and the total voltage. So we start with, when you're doing source superposition, you short out voltage sources and you make open current sources. So when I am looking at just the 9-volt voltage source, I will short out the 6-volt voltage source, so that becomes just a wire. And I'm looking for this voltage right here, so the voltage across that resistor. That's 1 kiloohm, that's 9 volts, that's 1 kiloohm, and this is also 1 kiloohm. Let's see, okay, so I know what I would do if this were my problem. So let's see if what he does, and hey, it's the same thing I would have done. Cool. Alright, so the first thing is, let's reduce these two resistors in parallel. Anytime you have identical resistors in parallel, the equivalent resistance is just half. So it would be 0.5 kiloohms. And now what we can do, this is 1 kiloohm, and we're looking for the voltage right here. We can do voltage division. So we know that on this side of the voltage source we're at 9 volts, and then the other side is, well, 9 volts less than that. So the total voltage from change from this corner going all the way up to here, that total voltage change is 9, and it's going to be higher here and lower here, and then goes back to there. So if we're looking for V1 right here, this would be plus and this would be minus. We will take our total voltage, which is 9, times the voltage across the resistor that we're interested in, which is 1,000, over the sum of the two resistances. This is 1 kiloohm, that's 0.5 kiloohms, so that's 1,000, that's 500, so this is 1,500 volts. And so let's see, so that's 9 times 2/3 or 6 volts. So V1 is 6 volts. Okay, so now we're going to find, so that's part A, and then for part B, we want to find the voltage due to the 6-volt voltage source alone. So I'll put that one in, put that one back in, and this time we'll short out the 9-volt voltage source. And, well, would you look at that, it's really the same sort of thing. So these two, 1 kiloohm in parallel, so I can put those together, and so I have plus minus 6 volts, so they're equivalent, except I don't want to do that. So my pen is not working. I'm looking for the voltage right here. Yeah, I do want to do that. I think yeah, and that's fine. I was at first I was saying, oh, I didn't want to do that because I was changing the thing that I was looking at. But that's okay, because what I'm looking at is voltage. And voltage is the same for anything that's in parallel. And so if I put it together with something that's in parallel, the voltage is still going to be the same. So that's okay. So this is 0.5 kiloohms. And this is 1 kiloohm, and I'm still looking for the voltage right here. And so once again, I can do voltage division. So V2 will equal 6 volts times the voltage that I'm looking at, which is 500, over the sum of the voltages, which is 1,500. So this time that is 6 times 1/3, or V2, is 2 volts. But I do want to be careful here, because you'll notice that there's something that's a little different about this one than last time. I mentioned it when I was drawing this one. I did not mention it so much when I was drawing this one. Look at what side is positive and what side is negative over here. This is the negative side, and this is the positive side right here. So this side, the bottom side, is higher than the top side. And so we do have a 2 volt voltage difference across this, but V2 is actually going to be -2 because this is labeled plus and labeled minus. But the plus is lower than the minus, and so we're actually going to have a -2 volts right here. Okay, so now what is V0? Well, V0 with source superposition is V1 plus V2, or 6 volts plus -2 volts, which is 4 volts, and that is our answer. That's weird. My pen does not want me to stop this recording, so you get to watch me stop it now.